everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get started. Problem. Solve d squared plus 5d minus 6 into y equals to sin 4x sin x. So firstly, let's find order and degree of the given differential equation. We can write the given equation as d squared y plus 5dy minus 6y equals to sin 4x sin x. We know that differential operator d equals to d by dx, right? Then d square will be d square by dx square. Then we can write d square y as d square y by dx square plus 5 dy as dy by dx minus 6y equals to sin 4x sin x. Now identify the highest derivative. Here d square y by dx square is the highest derivative, so our order will be 2, right? Here d square is the highest derivative, so our order will be 2, and the highest power of the highest derivative, highest power or power, right? We don't have any other d square y by dx square which is having highest power, right? So our degree will be 1, power of the highest derivative. Power of the highest derivative is our degree, right? Now coming to the problem, we are given a differential equation which is in operator form. Solution. Given differential equation, d square plus 5d minus 6 into y equals to sin 4x sin x, which is in operator form. F of d into y equals to q, where f of d equals to d square plus 5d minus 6 and q equals to sin 4x into sin x, right? Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function and yp is a particular integral. We'll find yc using the roots of auxiliary equation of homogeneous equation of the given non-homogeneous equation. Simply by taking RHS equals to 0, we'll get f of d into y equals to 0, which is our homogeneous equation of the given non-homogeneous equation, right? And we'll find yp using 1 by f of d into q. So firstly, let's find complementary function using the auxiliary equation of homogeneous equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we are having f of d, which is d square plus 5d minus 6. So by replacing differential operator d by m, we'll get f of m equals to m square plus 5m minus 6. Then our auxiliary equation becomes m square plus 5m minus 6 equals to 0. Then we can write plus 5m as minus 6m, okay, plus 6m minus m. Okay, plus 6m minus m is plus 5 and plus 6 into minus 1 is minus 6. Now take m common from the first two terms, we'll get m times m plus 6, and take minus common from the next two terms, or minus 1, we can say minus common from the next two terms, we'll get minus of m plus 6 equals to 0. If you notice, you're having m plus 6 in both the terms, so let's take m plus 6 common. We'll get m plus 6 into m minus 1 equals to 0. Now equate each factor to 0. Okay, from m plus 6 equals to 0, we'll get m equals to minus 6. From m minus 1 equals to 0, we'll get m equals to plus 1. Right? Then m equals to minus 6 plus 1 are the roots of our auxiliary equation. So here the roots are real and distinct. Therefore, m equals to minus 6, 1 are the roots of our auxiliary equation. M square plus 5m minus 6 equals to 0. Right? Which are real and distinct or different, we can say. So we know that when two roots say m1, m2 are real and distinct, then a complementary function will be constant, some constant into e power some root into x plus another constant into e power another root into x. Right? Then we can write complementary function yc equals to one constant into e power one root, say minus 6 or 1, anything, into x plus another root into e power another constant 1 into x. Then yc equals to c1 e power minus 6x plus c2 e power x is our complementary function. Now let's find particular integral. We know that particular integral is given by yp equals to 1 by f of d into q. We have f of d, d square plus 5d minus 6 and q equals to sin 4x sin x. We know that 2 sin a sin b equals to cos a minus b minus cos a plus b. Then take this to two RHS, we'll get sin a sin b equals to 1 by 2 into cos a minus b minus cos a plus b. Now replace a by 4x and b by x. Replace a by 4x and b by x. Now we'll get sin 4x sin x equals to 1 by 2 into cos 4x minus x minus cos 4x plus x, which is equals to 1 by 2 into cos 4x minus x is 3x minus cos 4x plus x is 5x. Right? Since sin 4x into sin x equals to 1 by 2 into cos 3x minus cos 5x, then this becomes 1 by f of d into, replace q by 1 by 2 into cos 3x minus cos 5x. Then we can write yp as 1 by 2 into 1 by f of d, or just write like this, 1 by f of d into cos 3x minus cos 5x. which is equals to 1 by 2 into 1 by f of d into cos 3x minus 1 by f of d into cos 5x. You can name the first term as yp1 and second term as yp2 for our convenience, okay? Now let's find yp1, yp2 separately. Firstly, yp1, which is equals to 1 by f of d into cos 3x. This is in 1 by f of d into cos ax or 1 by f of d into cos bx form for a equals to or b equals to 3. Okay, let's consider it as cos ax. Now we need to find d square, which is given by minus a square. For a equals to 3, we will get minus 3 square, which is equals to minus 9. Now let's see what happens if we replace d square in the denominator. Always remember that we should get denominator not equals to 0. Okay, if denominator becomes 0, the total term becomes undefined, right? So consider f of d and replace d square by minus 9. Minus 9 minus x is minus 15 plus 5d, or you can just write this as 5d minus 15. You can take 5 common from these two terms. We'll get 5 times d minus 3, which is not equals to 0, right? So now we can replace d square by minus 3 square, which is equals to minus 9. Then this becomes 1 by, now we'll just write the steps, same steps here. Okay, replace d square by minus 9, we'll get minus 9 plus 5d minus 6 into cos 3x, which is equals to 1 by minus 15 plus 5d into cos 3x, which is equals to 1 by 5d minus 15 into cos 3x. Also you can write this as 1 by, take 5 common, you'll get 5 times d minus 3 into cos 3x. Now we are having yp1 equals to 1 by 5 into d minus 3 into cos 3x, right? So we can write this as 1 by 5 into 1 by d minus 3 into cos 3x. See, in the denominator you are having d minus 3. So what we can do, we can just multiply and divide by d plus 3. Okay, just change the sign, minus to plus, then you'll get d plus 3 into cos 3x is equals to 1 by 5 into 1 into d plus 3 is d plus 3 by, we can write it as d minus 3 into d plus 3 or d plus 3 into d minus 3 into cos 3x. Here we have denominator which is in a plus b into a minus b form. You can write it as a square minus b square, that is d square minus 3 square into cos 3x, which is equals to 1 by 5 into d plus 3 by d square minus 3 square is 9 into cos 3x. Again, d square appears in the denominator. Now let's see what happens by replacing d square by minus 9 in the denominator. Okay, always we have to get denominator which is not equals to 0. Denominator must be not equals to 0. So consider the denominator d square minus 9 and replace d square by minus 9. We'll get minus 9 which is equals to minus 18, which is not equals to 0. Since denominator is not equals to 0, by replacing d square by minus 9, so we'll replace d square by minus 9. Okay, then we'll get 1 by 5 into d plus 3 by, replace d square by minus 9. Again, I'll write the two steps. Okay, which is equals to 1 by 5 into d plus 3 by minus 18 into cos 3x. You can just write this as 1 by 5 into, you can split this as 1 by minus 18 into d plus 3 into cos 3x, right? And you can write 1 by minus 18 as minus 1 by 18 into d plus 3 into cos 3x. This becomes 1 into minus 1 is minus 1 by 5 into 18. 5 8s are 40, 5 1s are 5, 5 plus 4, 9, 90 into d cos 3x plus 3 cos 3x. Is equals to minus 1 by 90 into, we know that d is a differential operator, which is nothing but d by dx. This becomes minus 1 by 90 into, find the derivative of cos 3x with respect to x, you'll get minus 3 sin 3x plus 3 cos 3x. Now we can take 3 common from these two terms, or you can take minus 3 common from these two terms. Okay, here also you're having minus. If you take minus 3 common, minus gets cancelled. Okay, let's see what happens. Is equals to minus 1 by 90 into, we are taking minus 3 common. Okay, minus 3 into sin 3x minus cos 3x. See, minus 3 into sin 3x is minus sin 3x. Okay, 3 sin 3x. Minus into minus plus 3 into cos 3x is 3 cos 3x. We'll get the same thing, right? Now, is equals to, you can just remove this brackets. Minus 1 into minus 3, or 3 1s are 3 30s are 90, right? Minus into minus plus 1 by 30. You'll get 1 by 30 into sin 3x minus cos 3x, or sin 3x minus cos 3x by 30. Okay, so we got the value for, or value of yp1. Now let's find yp2. 1 by f of d into cos 5x. This is in 1 by f of d into cos ax or bx form, right? Now we need to find d square, which is given by minus a square for a equals to 5. You'll get minus 5 square, which is equals to minus 25. Now let's see what happens if we replace d square by minus 25. Always we should get denominator not equals to 0. Denominator must be not equals to 0. D square plus 5d minus 6 equals to, replace d square by minus 25. Minus 25 minus 6 is minus 31 plus 5d. Or you can just write it as 5d minus 31, which is not equals to 0. So we can replace d square, right? Replace d square by minus 5 square, which is equals to minus 25. Then we'll get 1 by minus 25 plus 5d minus 6 into cos 5x, which is equals to 1 by minus 25 minus 6 is minus 31. We'll just write the same steps, which is equals to 1 by 5d minus 31 into cos 5x. Now yp2 becomes 1 by 5d minus 31 into, see we are having 5d minus 31. So change the sign, then you'll get 5d plus 3, right? So we'll multiply and divide with 5d plus 3, sorry, plus 31 into cos 5x. This is equals to 5d plus 31 by, you can just write this as 5d plus 31 into 5d minus 31, which is in a plus b into a minus b form. You can write it in a square minus b square form, into cos 5x. This becomes 5d plus 31 by 5d square, that is a square minus b square into cos 5x, which is equals to 5d plus 31 by 5d whole square is 5 square into d square. 5 square 25 into d square minus 31 square. 31 into 31. 1 ones 1. 1 3 is 3. 3 ones are 3. 3 3s are 9. 169. 961 into cos 5x. We have yp1 equals to this one, right? Again, d square appears in the denominator. So now we'll see what happens if we replace d square by minus 25 in the denominator. Always remember that the denominator must be not equals to 0. Consider denominator and replace d square by minus 25. 25 into 25 is 625, right? 5 5 is 25. 5 2s are 10. 10 plus 2, 12. 2 5s are 10. 2 2s are 4. 4 plus 1, 5. 625. You'll get minus 625 minus 961. Is equals to minus 1586, which is not equals to 0. So we can replace d square by minus 25. Then this becomes 5d plus 31 by 25 into minus 25 minus 961 into cos 5x, which is equals to 5d plus 31 by minus 625 minus 961 into cos 5x, which is equals to 5d plus 31 by minus 625 minus 961 is minus 1586 into cos 5x. We can just write this as minus, we can just write this as 1 by minus 1586 into 5d plus 31 into cos 5x. Write 1 by minus 1586 as 1 minus 1 by 1586 into 5d cos 5x plus 31 cos 5x. We know that d is a differential operator. We can write d as d by dx into cos 5x. Here we need to find the derivative of cos 5x with respect to x, plus 31 cos 5x, which is equals to minus 1 by 1586 into 5 into derivative of cos 5x with respect to x is minus 5 sin 5x plus 31 cos 5x. This becomes 5 into minus 5 is minus 25 sin 5x plus 31 cos 5x. Here there is no possibility of taking common. Okay, you're having 25 and 31. So we'll just write it as, okay, you can just write it as minus 1 by 1586, right? Fine, now this becomes minus 1 by 1586 into Firstly, write the term involving positive sign and then term involving negative sign. Or you can just write it as minus 31 cos 5x minus 25 sin x, sorry, sin 5x, right? By 1586, which is our YP2. Now coming to YP, we are having the results obtained from YP1 and YP2, so we can replace them here. We'll get 1 by 2 into YP1, result obtained from YP1 is sin 3x minus cos 3x by 30 minus result obtained from YP2 is minus of 31 cos 5x minus 25 sin 5x by 1586 is equals to 1 by 2 into sin 3x minus cos 3x by 30 minus into minus plus 31 cos 5x minus 25 sin 5x by 1586. Right? Now, we got YP. So now we can write the general solution. The general solution is given by y equals to yc plus yp. Then we'll get y equals to yc, c1 e power minus 6x plus c2 e power x plus 1 by 2 into sin 3x minus cos 3x by 30 plus 31 cos 5x minus 25 sin 5x by 1586. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.